How are you doing? Welcome to the 11th episode of the Sunday edition of Ask Lars Live. So, what is this? If you're not already familiar with this is where I try to attack a bunch of my emails, about 16 of them. We have some good ones today, like the 3D printer is turned on. We're going to talk a little bit about CAM, we're going to talk Sculpt, we're going to talk pretty much anything, mesh files, all kinds of great stuff. So, if you haven't subscribed yet to the channel, I would truly appreciate if you do that. I know many of you have. I also know many of you haven't, but it would mean the world to me. Thumbs up if you like this. Thumb down if you don't. That's okay. And, your comments, I read them all. Really appreciate all you guys taking the time to do that. So, let's just jump into it. I'll hammer through these 16 emails, and then we'll chop them off, and you will see them coming out on the channel as short versions during the week. The first one it's called Workflow for Costumes. And this one is from Ash Hill. It says, hey Lars, I picked up Fusion about a year ago on a hobbyist license. Cool, yes. If you are making less than $100,000 a year with Fusion, you can run Fusion absolutely for free. And for my family's various costuming projects. While your channel has been a wealth of information that helped me on many occasions, I'm truly happy to hear that, Ash. I find that I still struggle on establishing a workflow when creating models from 2D images that will effectively allow me to integrate more complex geometry and maintain clean transitions between bodies and faces. So what I'm thinking here is Ash is working, I didn't have a picture with this, Ash is working with costumes, right? Like, I'm thinking like futuristic things. So there's a bunch of different things we could attack in here as, but let's jump into maybe not Fusion first of all. Let's go out and do a Google. And, if I do a little bit of search here on the sci-fi armor, doing an image of something futuristic, this is kind of like maybe what I'm thinking you're working with, Ash, where you're trying to do something like this. And what is the best workflow inside of Fusion with something like this? How would I attack this? Well, let me tell you. Hope this is useful. You let me know if it's not. So inside of Fusion, clearly, anytime we're talking about working in an environment of like doing what I call swoopy surfaces, we are definitely leaning towards using the sculpt environment is definitely your kind of like breakdown. But, I think that from a sculpt area, you're probably looking and thinking, all right, that's great. But sculpt really just leans against doing one. I would actually use probably the same approach as you've seen me use before. We talked about master modeling and different layout sketches and things like that. You could do that within Fusion. What you could do was you could break this down. Maybe you have a sketch and a first sketch that's kind of like is gonna rule everything. Maybe you have like a kind of like a torso length, that is a certain length, and where you maybe have your head shape here, and I'm making the stick figure man right now, right, where you could have some arms coming out of there. You could have some legs coming out of there. But all this might actually be dimension, right? Like you could kind of like lay out the costume layout of this. And that will be your layout sketch. Then you could have multiple of these. And then you could start breaking it down into components. So now you could right click, say new component. And that might, in this case be the helmet or the hat or whatever you had there. There could be another component in here that would be, the body armor. That's probably how I think I would kind of start breaking it down if I was actually putting some thought into it. And then each of these would be, you activate that, and then that would be create your form. And that could be that you are now somehow in here creating that shape that you're going to use for that. And we have been inside of the sculpt environment before, right, where we can start working with different shapes, working with the different models. If you've had Fusion for a while and you've seen my videos, you've seen me working in it before. So there's your helmet, and then your body armor might be finishing this form here, going into your body armor, and maybe activate sculpt for that. And that might be another shape that you are working on in here, where you now are working with this as as an environment, right? So you can go this way, you can go symmetrical. We can kind of like start placing your body armor in here for your costume. You can break that down into the details and things like that. But the idea is that if when you go up to your top part in here, is that then you kind of have your whole shape that could be kind of controlled by those over beginning sketches, and then you have kind of like each one broken down as a component. It could be multiple components within this, right? You could start creating more components, make it as kind of a sub component within that. So your helmet might now contain some multiple components within that. That could be a front of the face, a back of the face, and stuff like that. So I think this is kind of like where I would break it down, Ash, as a layout within this. So you're still using the same structure as you would use within, if it was some more mechanical design, but instead of using the standard suite and stuff like that. But of course, you could do for some of the things, your sculpt, create the form is probably your main one. I hope that was useful. If it was, thumbs up. If not, thumbs down, and leave me a comment and maybe shoot me another email. We can take a look at it. By the way, my email address is down in the description of this video, lars.christensen@autodesk.com. And this is what I do with them. I can't answer them all, but I try to answer as many as I can. The next one is from Black Cat Forge, or AA, who sent me an email and also sent me a picture. So let me just call that picture up here. Actually, there's a couple of emails from AA here. Below is a shop I designed for the rants, walkthrough doors. But I'm talking about the big bay doors, something like the big garage doors we're seeing over here. Don't really have two, but I think it would be fun to have them in and movable, like the walkthrough, like normal doors. So I guess that in this model you can open these doors, but you don't have these in yet. Though that I understand there's a lot of moving parts and probably won't fit in a 30-minute video, I kind of had an idea, but my idea involves a lot because there's a lot to building these kind of garage stores here. So is there any faster and easier way to kind of go on and do this? And this, I think, is kind of funny. This here is actually, this is worth talking about for just a couple of minutes, because this is also what, not only, I don't know exactly, what you do for a living, but talking about, like, should we say, other programs such as Fusion 360. So at Autodesk, we have something called Inventor, what is, I would say, our best 3D CAD that can handle, thousands and thousands of components. But then we also have another program called Revit, what is for the building industry. So one of the things we talk a lot about is manufacturing for the architecture and construction environment. So for example, you will use something like, it could be Fusion, it could be Inventor, to make an air conditioner unit that goes, for example, on, a shopping mall. And that air conditioner is full of details, have every bolt, nut, pipe, whatever, right? Because that needs to be manufactured. So you would use Inventor for something like that. But then the architect that you're using, Revit, would like to have the whole building, would like to have the air conditioner on the roof. But do they need that to all its details, right? The architect don't really care about the air conditioner with all its, nuts and bolts and pipes and everything in it. because he just needs it more for like an area. So the reason I want to talk about this is how detailed do we want to go when we are creating things like that. And just to give you an example, if we go back into Fusion, if you go out here, and I honestly don't know where this is located, but if I search garage, you will see, so I'm going to just take a second, searching the internet here. You will actually find that I have modeled up the garage that I'm sitting in. Because when I started doing my workshop, so here it is. Let's open up this file here. What you're actually seeing right here is actually my desk that I'm sitting at right now. Some of you guys, there's actually a video out on YouTube on where I'm putting this desk together, where I'm going through, kind of see this broken down into different sections. I actually have my YouTube channel called up here. So if you go to Make Anything, and you go, which one was it? Biggest one-man desk in New York. There you see that is my desk you just saw a quick view of. But in that video, I actually go through and laying out this desk. And I actually also, I make it. So in the end, that should be, there I am putting it together. That desk is what you're seeing in there. So, and this, you know, eating my own dog food, I probably have to admit that this is not a perfect model. To be honest, let's turn on, actually, this is actually a multi-body. It started out being multi-body. If I turn off the desk here, this is my garage, my workshop garage, where I'm actually sitting up on the second floor here. You will see there's two garage doors. There's a big bench. There's a staircase that is not modeled up. And by the way, if I hit A in here, you will see that my appearances, I have thrown a glass appearance on here. So I'm going to delete that. So here you can maybe see it a little bit better, where we have a couple of garage doors. I have the office wall. So this is my office where I'm sitting right now, up here on the second floor. That table I broke down. But what I wanted to show you is that in here you will actually also see that I have some different sections. I created some different section views in here. You will see that there is one called the Dodge Caravan. That is actually the wife's van that is parked in there in the winter time. That is just a block. There's also a Honda Civic that used to be the wife's before I'm not driving around in it. And I also see I had a Tormark in here. I was trying to fit in a Tormark at some point. That project have kind of died a little bit. But my point is, how detailed do we want to be when we are creating things here? So very similar. I didn't go as much details as AA has, because in his he has the doors. He has the doors in here. And his maybe is a little bit more, detailed. But the problem with going too detailed when you're modeling things up like this is, of course, that the more detail you're putting in here, at some point, the software is going to start bucking down. So I kept this very crude right now. We can all agree on that. But if you wanted to start adding detail into it, there's a couple of different ways you could do it. So if we, for example, look at these garage doors openings here. So right now they're just cut through. So let me just first of all tell you how I would do this if I was going to model this up personally. If I decided that I was going to put the garage door in there, I would probably model one that would be open and one that would be closed. One on each side. And my reason for that is that as soon as we start, and I would probably just do it maybe even as one kind of like a body environment, because I'm really just looking to show that one can be open and one can be closed. The more detail you're getting in there, the more heavier the model's going to be. And at some point, it's going to start struggling. It's just the nature of a mechanical CAD software like Fusion, Inventor, SolidWorks, and those stuff. At some point, you're going to start running into issues. Now, if you're comparing just talking Autodesk, Fusion's going to hit that threshold a lot sooner than for example, Inventor would. Inventor is what I call big boy CAD. That would be able to handle all of this, where Fusion probably would at some point. So for me, it depends on what your end goal is. For me, I would model one where the door would be closed, and I would add one where the door would be open. But probably still put in, the rails and stuff like that, and break it down into the different movable sections. Now, if you did decide that you do want to make this more detailed, you want more stuff in there, then one other thing you could do was that you, instead of just modeling it up all within one file, is you could kind of start bringing it in to the specific file, right? As kind of like keep them separate. What probably would make, if you want to get into all the details of the garage doors, it probably makes sense to kind of break it away from the main building, just because the file's going to be too big. It's going to be hard to handle. You're going to start having a hard time figuring out where the heck you are here. So one way to do that is, if you're looking up at our Triad here, you can see that I modeled this with the old Triad system. One way to do this would be, okay, let's look at where the origin is on my model. And I was actually made a decision when I started modeling up this whole garage that I created a 0, 0 corner. You can see that corner down here, because this is where I normally come in every day. So this is my 0, 0 corner. So one thing you could do was we could measure from that corner. We could measure over to maybe where the garage door starts. So you see this was done in inches, 206 inches. We can remember that. And if we're looking at the big garage door, maybe we're looking at how wide that garage door is. It's about 117 inches and 118 inches tall. So what you could do, the way I would do this, would be, let me just close that out, would be I would open up a new document, and you can see that my Triad have kind of like flipped around here. So I'm just going to go up and change that back to how I used to have it, what used to be the Y direction. Apply that for a second. Open a new document up. There we go. So the reason I'm doing this is because I want to make sure this aligns. So if we're looking at the front here and looking at the front here, if I turn the origin on, I would start creating my detailed garage. But if it's going to be details, now we're talking probably about components. But I would do a layout sketch on the front plane. And let me just draw a rectangle here. And that rectangle is going to be, oh, I'm in, hang on. I never switched the units over either. I like to do my videos in metric because Americans switch back and forth. It is a little harder for us Europeans. So in inches, I would go ahead and create the garage door opening here. So it was 118 and 117 wide, I think it was. And then we maybe do like a coincidence between there to the origin. And then I would place that dimension from the origin to here. What was 206? Right? So I'm drawing up now a file where, finish the sketch, where I'm using that origin and I'm now drawing from that origin in my new file. And now you could start breaking this down into new components, because you know that this garage door is going to have a million different components in here. So let's just go ahead and, extrude something so you can see what I'm talking about. So this part here would have all these different components that there is inside of a garage door, how detailed you want to get. But what happens is that when I save this, I'm just going to save it. I don't even know where the garage is saved. I'm just going to save this into our project. When I go here and I now say, all right, let me insert the door I just saved. Oh, sorry. When we go in here and say insert into our current design, it's giving a warning that it will not be linked because they're two different projects. I don't know where the garage, I can't remember where to install the garage. But what you will see when I bring it in, you see how the new garage door comes in exactly on the right place? You see that? Like it's located. And if I had them in the same project, they would be linked back and forth. That would be the ideal thing for me to do, to have them in the same project. Now, what this means is that, I'm not going to save this, is that in our door project, if I open that up, I could now do all the details in here, but I know that, you know, it's placed in the right place. And the reason I would do this is that this would mean that I don't have to worry about, I wouldn't have to worry about joints and things like that. They're kind of like just falling into place. So I hope that this was useful for UAA, just in the sense that when you're working, let me bring AA's garage back on. When you're working with something like this, how detailed you want to go is up to you, but know that the more detail you're putting in there, you know, the worse it's gonna get. And then somebody's gonna ask me, how much is too much detail? I did the plastic injection mold, what is probably my biggest assembly. I think it has about 200 to 300 components in that one, and that's not a problem. That one is reacting perfectly fine. I would probably think that with Fusion 360, when you hit about I don't know what, it depends on a lot of things, but you know, if you're getting over that, if you're getting to between 500 and 1,000 components, you probably have to start being very calculated about how you do things, and you might see some performance issues. So you might want to test it around. That's why, for me, it's all about what is your end goal. Fusion 360 as a mechanical CAD software is not a great software to make a movie where you're walking through the garage and doors are opening and closing and doing all kinds of crazy things, because that's just not that software for that. I hope that was useful. Thumbs up if you like that. Thumbs down if you don't. I'm going to take another one from AA. The next one here is Lars just had another topic for today. Being a blacksmith, I put a lot of twisted metal. That might be a quick and dirty way to do that. So let's just open that one up. So what we got from AA here was this image of something that needs a twist in it. So like what you would do as a blacksmith is you would heat it up and, you know, twist it. Heat it up and twist it, and though I don't, yeah. So how would you add a twist to this? Oh, I didn't share my screen. Sorry. Now you can see it. So if you have a rod like this, how would you add a twist to a rod like this? And you can see there's actually kind of like a feature down here. So you would heat it up with a torch, and then you probably just twisting it. There's different ways to do this inside of Fusion 360 for sure. Actually, let me just go back into my preferences and switch this back to Z up. That's what I prefer. Move on here. All right. There's different ways you can do it. One that you probably would lean yourself to is to use the create form. That would definitely be perfectly okay. Another way to do it, and that's why I'm doing these videos, is just to show different ways. So let's just look at the image we had here again. There we go. So we had kind of like a round piece, and then it turns into like a square that we want to twist. One way to do it would be to go up here and let's see for circle. Let's make this 50 maybe, extrude that out. So there's our round piece right there. Now, if we just went ahead and start another sketch here and do my S key to find my center rectangle, maybe we make this 80 by 80. Of course, if I hit Q for press pull, then we kind of have what A is pointing out there, but we want to twist this. There, like I said, form could definitely be one way to do this, but another way I want to show you, because I think that this could be useful for some people, was to just create this one sketch here and leave that, and we could use the loft command. So what I could do is I can go up and say offset plane, and click on that one up there, and then we could offset this out, I don't know, 20 maybe, offset that out 20, and then I could draw on that to create a, on that face, and if I do the same thing, draw one that is 80 by 80. So what do I have right now? Oh, sketch in the wrong plane. Hang on. You can actually define your sketch plane. I want it to that one. There you go. If that went a little fast, go back and watch that. I sketched on the wrong place first, so I put two sketches on top of each other. Now, what you could do was you could hit M for move, and you get the move command. Change that to sketch geometry. I'm just going to highlight this whole thing, do a window over it. I'm going to set the pivot by click on set pivots. I'm going to move that back to the origin here and hit the green check mark. And now if I grab this, we could actually start rotating this. So maybe we rotate this minus 30. See that there? And we can continue this process how depending on how twisted you wanted this to be. So let me do another 20 from that one, like that, and we can kind of rinse and repeat. Open a sketch on that plane. S key for my center rectangle. We did it 80 by 80, like that. So now we have that one, right? So now we have those sketches. And then if I hit the M for that and just window that sketch, I'm going to change the pivot to the center there, hit the green check mark. Now I maybe decide to do this one minus 60. Right, so now we kind of have those here, and then maybe I do one more where I'm saying that now the twist is going to be over. Let's do another offset. Let's see the last construction plane right there. We made it 20, and let's just create one last one that is like the first. We could actually project it. That would actually probably be easier. So it's just P for project. And double click this one, and we get that last one out. That's a projection. So what I have now is kind of 4 sketches, one standard rectangle, 30 degrees, 60 degrees, and then back to normal. And now if we go in and we use the loft command, sitting right underneath create, we select that, select that, select that, select that. You will now see that we have a twist. And depending on what we do with, you know, how we did these different planes. So if I decided to go in and edit that last plane we created, and instead of having a 20, I decided to make that 40, that will be longer. If I go in and I could now move all of them that amount, that 40. That would just make the twist, however more I wanted to twist it and how much longer I wanted to do it. And this could actually, this could be actually control this with a parameter. Somebody will tell me if we wanted to do that. But that's one way to literally take and twist something around like that. I hope that that was a little bit of useful trick here. Square bar with a twist in it. That's how I would do that. All right, next one here is one that I really am excited about sharing. If you like this, thumbs up. Thumbs down if you don't. Love the comments. Subscribe. You guys are the best. I'm just trying to answer some of my emails. Next one is from Chris. I am brand new to AutoCAD and 3D printing. I think you mean Fusion 360, but that's okay. Autodesk, the AutoCAD company, whatever you want to call it. I've been watching your Absolute Beginner series and love them. Do you have a intermediate series, or at least some recommendations of which your videos will show you next? No. We're going to this topic is about OBJs versus STLs. But before we get to that, I have a dream that someday I will get all my channels. How many of you guys are watching John Saunders? Raise of hands. Raise of hands. I'll raise my hand. John Saunders has done a great job with his YouTube, with getting his YouTube channels to his website, NYCNC. I do have a website called catcamstuff.com. Actually, some of you guys have probably gotten the free CNC handbook that comes out of this. My dream is that someday I will get like an intern to come over here and help me turning this site back into what this site deserves. But what I have done in here is that I did so that there's the absolute beginner live stream recording as a playlist. And if you haven't watched this one, if you're fairly new, that is probably the one I recommend that you go and take a look at. I think that these are my best attempt to create kind of like a from beginner to intermediate. And I think these 14 videos, when you get through these 14 videos, I think you can pick pretty much anything else on my channel and get to that. But let's get back to the fun part of this next one, and that is to talk about OBJs versus STLs. So, Chris says, I have a question about OBJs and STL files. I'll be using a SnapMaker 2. I don't really know what that is, but in the documentation it says it accepts OBJs and STL files. My question is there any advantage of choosing an OBJ over an STL in 3D printing? It really depends a lot about like your 3D printer. So I think you're right, because you're saying that part of your understanding of an OBJ file is that there's more information in it than there is for an STL file. And that's about right. There's a couple of different, and I'm not going to say that some people out there who know more about this, please feel free to comment, share the knowledge. But there's a couple of differences between an STL file and something like a OBJ. So first of all, yes, you're right. The OBJ can have more content in it than an STL file, for example. So it could be, many times this comes out of like scanning a surface. I've talked about STL files before. It's triangular, right? OBJ files can also be, I think they can actually be triangular, but they can hold more information like color and surface texture and things like that. Not something that we really care much about from a 3D printing standpoint, because in a 3D printing standpoint, we're looking for the raw thing. But if you're scanning, then the texture, the surface texture, color could be interesting. The other thing with an OBJ file is that it can be quad mesh. So STL files, and we've talked about STL files before. STL files in our normal kind of environment. Remember, a couple of weeks ago we did Kathy's STL file here with the Bonnie. We talked a lot about STL files and converting STL files, that they are triangular meshes. I'm not a big fan. So I am more of a fan of an OBJ in the sense that an OBJ can be quad. So what I mean by that is that the STL file here of the Bonnie is these triangular shapes. What is really just, is really just points where you're creating a triangular flat between them. And like I've said before, the problem with that, most of the stuff with STL files, is that we normally can't control how accurate this gets. Now with OBJ, it becomes a little bit different. So if we go in, and I did download an OBJ file. If I go and we insert the same way we do a mesh, we go and say insert a mesh, because an OBJ is still a mesh. And I downloaded this free sword that I found online, because our first question from Ash was in regards to costumes and things. Now you will see here on this, if I zoom in, that this is not triangular shape. This is actually quads. So that means kind of the same idea as before, that it is, a points, because if it's scanned in, it's points. But instead of being triangular, what makes it more, rough, we can now make a quad, what makes it more precise. But on top of that, because Fusion 360 is awesome, we can actually turn a quad, what is again 4 points into a flat face, into a form tool. Woohoo, if you didn't know this. So if I go up here and we turn on our capture design, remember we like to do that when working with meshes. We turn that history off by right clicking up here and turn that off. Now we actually get an option that we can right click, and instead so what we normally do with STL files is we're turning the mesh to a B-wrap, what turns it into a solid. We could do the same thing here. But if you go to the convert, you actually now get an option to turn a quad into a new T-spline body. When I do that, and it's going to take a couple of seconds for it to convert it, of course, but what happens when we're doing that is that now we get this T-spline environment where we can start pulling and shaping and things like that. Now, if we were looking to turn this into just to 3D print this as it is, if your 3D printer takes OBJ files, then that's not a problem, right? Then you can just go ahead and open that OBJ file up inside of your slicer that you're going to be using for 3D printing this, and there's no reason to bring it into Fusion. You can just completely eliminate Fusion. But if you're like me, where you actually, and we're looking at this, you will see that now that mesh of the OBJ have been turned purple, what means that this is now mesh files. I can actually go into body number 7 here. I can right click on that, right? And I can now go in and I can start working with that body. Form here. I can literally now go and select, let's see here. If I just only want to, there we go. So I could now go ahead here and select these two faces, right click, edit form, and you will now see that I have sculpting tools where I can now modify this shape, whatever I want. As you've seen me using sculpting tools before, so you can start manipulating it, turning it into whatever you want. So that is definitely something that is super awesome about OBJ files, right? That instead of turning them into we've done this in previous live streams. STL files, triangular mesh, we can convert it into a solid, and then we could start, cutting through it and do different things with it here. With the OBJ file, we actually turn it into a T-spline that makes it, a lot cooler. We can move around with it and things like that. And then we could convert that T-spline back into a solid, and then of course 3D print it from there. But if you have an OBJ file of something that you don't need to manipulate, and your 3D printer can take an OBJ file, then you maybe don't need Fusion. I thought this was a good one to kind of talk about that magic of an OBJ file. So OBJ files, definitely, I love them more than I love STL files, because they give me the opportunity to get into T-splines and pulling and doing things with that there. All right. Thank you, Chris. I hope this was useful. Thumbs up if you like this. Thumbs down if you don't. Yeah. Let's move on to the next question. Next question is from Doug. Doug, love all the videos. Thank you so much. Helping us all to learn. Yep, that's what this is about. Just trying to add a little bit more value to your Fusion 360 experience. So I have a cam question. I love that. Attached is a picture of a snapshot of a piggy bank for kids. Oh, let's take a look at that. Let's move on from Chris's sword. And let's open up this picture. Looks something like that. A piggy bank for kids. It's kind of cool. So the slot in the picture is where a tube where the coins slide down into the bank at the bottom of the part of the bottom. It is open all the way down so the child can see the coin. I see that the bank has most of the channel completely cut through for visibility and only halfway deep at the top. I'm sure two mills were used, a flat end mill to make the visible channel part, and then a slot cutter to make the channel for the coins to slide through. So yes, I'm missing a little bit of, maybe this is just the difference between you and me in regards to visibility. It looks like two different parts, right? So I'm thinking this is like a plastic part, and then there's a clear plastic part down here. And my thought is that the kid lets the coin kind of like slide down. I don't know how big this thing is. Slide down, and maybe I need a better picture of this. But I don't think necessarily, I think one end mill is used to mill all this, but in two different setups or in two different depths. The first one don't go all the way through, and then they just mill it all the way through to the end. And if you're into cam, I thought I would do this to show you some pretty neat stuff that you maybe don't know about cam. Maybe this is answering your question, Doug, on how I would do this, maybe not. But I thought this could be kind of cool. If you're a cam user, I hope I show you something you didn't know. Let's just go ahead here and S key to get my center rectangle. And I'm going to do, I don't know, 300 by 200. And let's just extrude some thickness to this plate here. Let's make it like 10 millimeters thick. So what I thought we will do with this is we will go in and insert a canvas on that front face, and we're going to take our piggy bank. Open that up there. Let's go to the front view and look at this and scale it up a little bit. It actually flipped on me. Did you know this is the flip button? You know, you can flip a image like this. I'm just going to get this up a little bit here. Stay within the box. Okay. I want to show you a couple of cool tricks. Now, first of all, I need to create the path how I would mill this. And the way I would probably do this is with splines. We talked about, if you are into modeling, talked about splines before. Start a sketch on that front face, and I'm going to use the spline tool. Now, somebody pretty cool out on Facebook, somebody had a question about splines, and other people were super cool to help. When you do splines, it's not so much about many points. It's more about where does the spline kind of switch direction. So you will see, I'm going to show you that just in a second. Now, I know this is for cam users, but I think cam users will love this too. I'm just going to go to about this point here, because with splines, you get these handles. And with spline tools, you can actually kind of like adjust this to be about as good as you want it. So these handles you see here is kind of the magic to make these follow the groove the best you kind of can. So see how just by moving these points, we can actually kind of make this work. I'm not sure I got that right. Make this work pretty close to the channel of this model. So if you ever see somebody struggling with spline points, it's normally just because that they're putting too many in. You really just need wherever it kind of follows around. So this channel here is kind of following pretty good all the way around here. And actually also another thing that I've talked about before is that these handles you can also use like constraints. So you would maybe make this one vertical here, just to kind of have that as an option. I was going to change the spline a little bit. And whenever you get everything spline wise the way you want it, when you kind of feel that this is pretty good, then it's okay in my mind to right click on the spline and just fix it. So we normally don't fully define these splines, we're just fixing it. Now I'm going to do another thing. I'm going to create a line from that end point up there till out to the end. So this is just a straight line attached to the sketch. I'm going to stop this sketch right here and show you what I got. I'm going to turn the canvas off. So what we kind of have is a line that goes in and follows around here. Now this is where it becomes interesting for cam users, I think. I hope. um, Check this out. We actually don't need to have cuts and extrudes to use cam. What we could do is we can go in here and go into manufacture, and we're going to do a setup. So I always going to do the select z-axis direction. I'm going to select this top face, and now you could place wherever you kind of want your point at here. Oops, sorry. Let's select this upper corner for my G54. And you can, if we go in and do a 2D contour, and we're going to select an end mill. Let's go in and find our metric tools. I'm going to select a flat 5mm end mill here to do this. When you come to the geometry tab, check this out. If I select this line, I get just one line. Now you might choose again to select the spline. When you do that, notice how we kind of get two different arrows here. And the arrow shows what side of the cutter do we want to be on. So if I switch this over, flip that arrow, I can switch direction. Now I have two arrows and I have two chains. What that means is that I have made two chains to go through here. You can actually make this one. If I check the first one and I reselect it again, then we get this chain manager, right? And it has the one selected. We could actually now go over and select the next chain. And now when we hit the plus sign, it's one chain machining the whole thing. All right, I'm going to stop right there and hit OK, so you can kind of see what we have gotten out of this. What we have gotten out of this is we are just machining one sketch. We are staying on the left side of the sketch. And if I simulate it, you will see that that end mill is just kind of kissing the top of that surface. But this is pretty cool. I didn't model up all the slot and worrying about the slot. Now, don't forget that lead in, lead out might be an issue. Right click, edit the tool. And when you go to the linking tab, the last tab is all about approaching. You could go in and say my lead in is going to be, I don't know, it's a 5mm end mill. So maybe I make it 8mm, and maybe my lead out is not going to be there at all. And I hit OK. Now you will see I get a lead in that's going to be outside my part, and my lead out is just kind of like going to go up. So now if we simulate this, you will see that we're not going to worry about smacking into the material. Of course, we're not touching the material yet. So let's do that. Let's right click and edit the part again. Let's go to the heights tab, and you will see that if we go I've talked about this in other videos. If you're confused about the heights tab, start from the bottom and work your way up. So the selected contour is what we're machining. Well, the selected contour is that sketch line. So if I go minus, I think we made it 10mm. Let's go -8 first. So now you will see here, if we go in and we simulate that, let's turn the stock on and we hit play. You can kind of see how we're machining here. Now the material appears because we are driving a sketch, but it's kind of like the amazing thing about this. I'm going to turn the model off. Now let's go back in and simulate it. Right, so now you see here how we're making that slot of that picture. I just hope that this is useful to somebody who is fairly new to CAM inside of Fusion. That we now are actually camming a slot in a completely untraditional way. Now I wanted to show you the next part of this. Let me turn the part on again, because if you turn the image back on, our canvas back on, we are machining the slot to a certain level, but then down about here, now we wanted actually to start machining all the way through, if you remember correctly. So check this out. Go back into the manufacturer. I'm going to use a command I love to use, and that is right click and go down and just duplicate your previous toolpath. That means that the toolpath has all those things in it that we just have changed, the lead in, lead out, all this kind of stuff. And if we just duplicate that, we get a copy of that, now we can continue working with that. So a couple of things I wanted to show you with that. First of all, I'm going to go in and edit that. And I know the lead in, lead out is going to be a little, so I'm going to turn the lead in off. Here's one thing I want to show you. This toolpath is identical to what we selected before. Did you know that there's a tangible distance? And what that means is that if I say, like, I don't know, I'm just going to 60 millimeters, hit OK. Oh, I'm going to go minus 60 millimeters. Go the other way. Then now it starts 60 millimeters in, but it's quite not enough for me. Right click edit on that second toolpath. Let's make it minus 120. Hit OK. You see how it starts here now instead of starting all the way down? And we can separate the two. So I can say that I want my n to be 0. So now it's still not there. It doesn't start until there. But you know what I'm doing here? On the passes tab, I'm actually adding in 200. And I'm saying that my tangential end is 0. So that's going to stay there. But it's starting further in. Just leave it there. So let's go in and simulate this. So canvas is turned on. So the first toolpath, we've already run that through. That is just machining through there, right? But then the second toolpath is going to come over, and that one's right now is just going to start there and go to the end. But if we go back into that and change the cut through, the depth, I think I made it 10 millimeters, you might remember. Let's make it minus 11. Now if we go in and simulate these two, get to the last toolpath, it's going to move over, come down, and now it's going to machine all the way through that in the end. So have a good lead in, come around, machining to a certain point, and then go down. All done in our operation, not doing any cuts, but just following a sketch, and then going in here and playing with this tangential extension. That is pretty rad. So Doug, I really, really, really appreciate you sharing your your question. I hope that this was somewhat helpful, if not just to you, then others, to just see how you can literally have this kind of flexibility within Fusion 360. Hope that was useful. All right, let's move on. Almost an hour. Next one here is from Eric. Thank you so much for the web streams. Very educational. Thank you so much, Eric. My question is, if you can offset multiple planes, or do I have to do individual offsets for every plane? You have to do individual offsets for every plane. We did that model earlier. This one, you saw how I offsetted each plane individually. There is not a function in Fusion to offset a multiple of them. And then Eric answered with saying, is there a workaround if you cannot offset a plane? That makes me think that you maybe want to look at some of the other tools in this construct, in here. I did a live stream, or I did a video. If you search Fusion 360 construct plane, maybe go and check out last live number 20, where I go through all those different options inside of that one. I think that's probably the best one you're gonna come across. Hope that was useful, Eric. Next one is from Ian. Hi, Lars. I have learned a lot in the last couple of months from your videos. Happy to hear that. But doing this reasonably efficient way has stopped me. And he sent me a picture. So I will share that picture with you. Look at that. That looks like a fun project. Ian have played around with this and have talked a little bit about how he think he can break something like this down into pieces. And that I would definitely agree with Ian. I would probably turn this into like a pizza slice, right? Like trying to just model up maybe, you know, one portion of it and then figure out like it looks like it's symmetrical in some way. And then you could kind of like patterning it around if you're going to do something like this. But the question is, what about when it goes over and under? So you can kind of see how something is going under and something is going over. The only best way to do that inside of Fusion 360, I think, is to use the Sweep tool. This might not be, you know, this is going to take a little bit of work. But what you could do was, let's open up a sketch on the front plane here. And if we do like a 2-point rectangle, make this one 20 by 30, and use something like the Sweep tool. So we could go ahead and just make this straight, for example. Right, we can go ahead and make that straight, but you could also break this into 2 sketches. So if we so we have one sketch here of this one. If we go ahead and we open another sketch in the top view, we could draw a line out here, right? And then we could turn, whoops. And then we could go in and maybe do something like a 3-point arc on this, right? And then use the Sweep command. And we will get something like that. And that's probably also what I would do to create the over. So on the over, let's open up a sketch. Let's maybe do, just to make it easier, let's do an offset plane. So we get something over here. And let's draw a sketch on that. I'm going to do another rectangle. So what did I do before? I did 20 by 30. Which is going to keep something symmetrical. And I don't think I placed this. See how this one is floating around? So maybe do coincidence from here to here. And let's place a dimension from here to here. Remember that. That's 20. Because now I could go ahead and do something similar as you just saw me do. An offset plane from here. And that's going to be 20. So I make sure that that intersects with that. So if I open a sketch here, I could hit P for project and kind of borrow that point. And now maybe I go in and do, we just did spline before. And I could kind of model a spline that's going to go over here like that and use the spline. You could, you know, P for project this edge and do this point to, well, probably wouldn't do it to the midpoint because it's going to go underneath there, but just for the heck of it. Now when I do the sweep from here to here, I'm just going to do that as a new body. I know it's touching. There's an intersection arrow, but that's kind of like how you would have to model going over or under, unless, again, you go into do, you know, the foam environment where you can dragging and pulling and do crazy stuff like that. But this is kind of like your way in a mechanical CAD to model something up. And I would also say something like this, that's, you know, that's a good test for a mechanical CAD system. There's definitely other systems out there that maybe would work a little bit differently with something like that. But great question from Ian. I really appreciate it. I hope this was useful. Thumbs up if you like it. Thumbs down if you don't. Love your comments. If you haven't subscribed to the channel, I know a lot of you haven't. A lot of you have, and I love that. A lot of you haven't. If you don't mind, that would mean the world to me. If you think, well, only do it if you find this content helpful. If you don't, then don't bother. All right. Next one here is from Joe. Hey, Joe. Huge fan of your videos. Thank you so much for taking the time, man. Really appreciate you guys watching these. It's just my attempt to add a little bit more value to you, answering some of my emails here over the video, over the weekends. I'm sorry I can't answer all of them. I have learned a lot of you, but of course there's always the, yeah, but how do I do this question? What I'm trying to do is I'm trying to understand how to model something like this. And I thought this one was good. Shared this thing that he found on Thingiverse. So somebody else modeled up a towel rack holder kind of thing, and how do you do that? And I thought that was awesome. Whoever modeled this one up and shared it on Thingiverse, thank you so much. But of course, let's model one of these up. And as you can see, I turned the printer on because I thought maybe we just fire up the printer, take it all the way to the end. How do you like that? Good? So looking at Joe's, let me get a sip of coffee here. Looking at Joe's towel holder, clearly 3D printed. I don't really know how big this is. I haven't tested this out, so bear with me, right? Like I'm just, oops, that was the piggy bank we did. Where's the other picture? That one. I'm just gonna go with this, what I think might work, and then we'll kind of like have to see. I'll 3D print mine. Joe, you 3D print yours. Anybody else 3D printing those? Please send me a picture of it. Lars.christensen.com. You would absolutely make my day. So inside of Fusion, let's get out of the leaf here and move on. So when you're looking at this and you're trying to model something up like this can be kind of, I think this is a little difficult. Like my brain, everybody thinks that I know all the answers. I for sure don't know all the answers. And when you're looking at something like this and you're trying to figure out how do you model it up, it can be really, really hard. I'm looking at this and I'm thinking, all right, I can model up the flat face. And then I maybe need like two walls that is kind of like collapsing in. There's a lot of ways to model this up inside of Fusion. And there is no right way. When I see something like this and I'm thinking about I gotta model this up in one of my videos, I really try to think about how can I add some value to you? Because there's no one right way. And I wanna kind of like inspire you because some of you guys, I hope, are gonna model one of these up and send me a picture of it. But some of you guys are also like, this is stupid. I don't have a 3D printer. I don't give a hoot. So, but just so you don't turn off, I'm trying to do it in a way that you might find it interesting. What I'm actually gonna do is I'm gonna model this one up in a reverse fashion of what I think how most people will model this one up in. I have an approach that I call the manufacturing approach. And I really like that one whenever you kind of second guess what you want to do. Because, like I said, we could model up this flat triangular shape. The bottom, the flatness that goes against the wall. That might be easy enough. But then we got these two walls that kind of is going to come in at an angle. And that kind of gets complicated when you get down to where it points toward the center of the triangle. So what I do with the manufacturing approach is I'm thinking about, if I had a block of steel almost, how could I make this? And that would just be starting to cutting away at it. But then I thought, that's too easy. So here is a trick that you maybe not have seen. I'm actually going to start out by modeling up the triangle from this face here. All from kind of looking down from this direction. And hopefully some of you guys find this useful. I'm going to start on my face here, and I'm going to draw a triangle. I'm going to do it out of whack. I'm going to make it the worst triangle you've ever seen, because then I'm going to go ahead and use these constraints. I'll go ahead here. I'm going to say this constraint. I'm going to make sure that this here is horizontal. Then I'm looking at it. I'm saying, where is this origin? I want kind of like that to be a point of it. So I'm going to go up and say midpoint. The midpoint of this one to this point. Boom. Okay, that is good. Now I got to give it a length. D for dimension. And I think I'm going to make this 80 millimeters. Probably sounds about right. Okay, now I see that this is flipping around. This should definitely somewhere be isometrical. So one thing I could do is I could draw a line from this midpoint to this intersection, and then I could use another, make that line vertical, right? There you go. Now it's going up and down like this. Now I can do another D for dimension from this line to this here. And let's do that at 35. I'm just rounding it up. This sketch is now fully defined. You all will agree with me with that, right? Because it's black. So what I'm looking at right now is I'm looking at it from this side right here. If we're looking at this image, I am literally looking at it like this from the top. Okay? Let me show you what I'm going to do next. This is where I hope somebody is going to be like, wow, I've never thought about doing this. That's what I hope. I am now going to finish the sketch. I'm going to do a offset a plane this length way here away from my triangle. This length here right now is this length of where the point where it's going to meet down in the intersection down here. I don't know how long that's going to be, but I think that maybe 60 might be good. So let me type that in. Make that 60. Okay, now I'm going to open up a sketch on that plane. I'm going to create a sketch on that plane. But what I'm going to do is I'm going to hit P for project. And I'm going to steal that center point right there. That's all I'm going to leave in that sketch is that stolen point from there. Then if I go ahead and say I want a loft between this sketch to this point and I hit OK, you see what I've just created? I've just created that triangle. I hope somebody right now is like, whoa, I would never have thought of that. So we have that flat against the wall. If I spin it around, we're looking from it from the front. Now, if you look at the images, that is looking at it from the front. We don't have the opening. It's not hollow. It's just that solid manufacturable blank. Okay? Kind of cool so far. Now, I want to open it up and make it hollow. I'm going to use the shell command for that. I'm going to click the shell command. I'm going to click on the top of the rectangle, and I'm going to give it a thickness. I'm going to make mine 4 millimeters maybe thick. See that? Now it's hollow. With that shell command, that command up there, it's now is hollow. It literally what it does, the shell command in itself is pretty neat. The shell command, I clicked on a face, I clicked on that top face up there, and it makes that open, and then it literally makes a thickness of that 4 millimeters on all the other sides. What means that if we go in and do something like a where is our section analysis? If we're doing a section analysis of that back face, see how it's actually a tapered cut through. Okay? Alright. So that is that. Now I think I'm ready to create that opening that we see right there. So what I'm going to do is I'm literally going to go in and open a sketch on that inside face. I'm just going to spin it around here so we're looking at it from the top down. And don't forget, I've used this in a couple of my videos. Don't forget this sliding tool that will kind of slide the box. Uncheck so we can see where we're sketching. So now I'm going to create a line and I'm going to place that line. I don't know where this is going to be, but I'm just going to kind of like sketch down here. I'm going to make this flat. I'm going to sketch up to there. And I'm going to kind of like close that off. I'm going to do the same thing as I did before. I'm going to say that line, midpoint. Make sure to select that line. So that origin, right? I can create another line from this to this midpoint. And I could say that I want to make that horizontal. Okay? Somebody right now, I can't remember who emailed me that I don't make these construction lines. And that's bad modeling habit. Yeah, I maybe disagree. Just have to get that out of the way. I'm going to make this, I don't know what this is going to be. I'm going to try to make it fall, maybe. And I'm going to go ahead and make this length here. Maybe I'll just leave it at 30 for right now. And if I turn that slicing off, we have this sketch. And now if we hit Q for press pull, and we cut through here, what do we end up with? We end up with that opening. I hope I haven't lost you. Right? Now, I don't know if this is good enough that when you take that towel and you throw that in there, it looks like you kind of like take the corner and kind of stuff it in there. That's going to lock it in. I can't wait to test this out myself. I'm just going to 3D print it. I'm not sure if this is enough, but I think I'm going to leave it like this for right now and see this. Now, on this video, you would now put a couple of holes through it, right? So you could go in here and you could use the hole command and sketch holes or whatever. I'm actually not going to do that because my towels is hanging over the edge of the stove. So I actually think that I don't think I want a hole to drill through. I actually think maybe I'm just taking some packing tape or like some double-sided tape and put on the back. Maybe test that out. But what I want to do in the end is, and I'm waiting with this to the end, we want to add some fillets. I'm probably going to break up my fillets a little bit and maybe say internal fillets here on the outside maybe. I have always found that breaking your fillets down makes a lot of sense. I start out with 1mm fillets. That might be decent. Maybe we try 2mm fillets. I like to break it down into multiple fillets. So I don't normally fillet the entire model at first. I like to have kind of multiple fillets in here. See how this is. If we make this one 2mm, that might not be good enough. 1mm fillet here. It seems like it was failing down here. And then maybe we go and we add some outside fillets on the third one. And let's try that at 2. Another 2 and 1. Yeah, I think I like that. Maybe we make this one 1, 2 and see how that looks. Make them all 1. You can play around with this. So now we can make this one higher because it doesn't really interfere. Don't make it that. Make it 2. All right. So do whatever you want to do here in the case that you want to do some holes, whatever you want to do. But this is my attempt on trying to make the towel holder. Whoops. Sorry. We're going to get to this one. My towel holder. I lost my towel holder. This one. The towel holder here would be my attempt. So let's get back into Fusion. And then we're going to go and do tools. We should probably actually save it now. Let's hit save and call it towel holder. I hope this is useful for you. Save it and let's go make. 3D prints. I normally have mine set at medium. I have the Ultimaker behind me, so I'm gonna use the Cura. Hit OK to that. And let Cura fire up here. Hopefully, I just downloaded the latest version of Cura before we did this this long live stream. Come on, Cura. It's opening up on the other page. Let's give it a second. And there we go. There is Cura. Cura they just changed the layout. I haven't really looked at this much, but this menu used to be over here. That's kind of cool. So you can see I have generic PLA. I don't know if we need support material for this. Let's hit the slicer button down here. Slice it up on the Ultimaker. We can go in and do it's going to take 2 hours and 20 minutes. I have like a cool little verification here. You can kind of see that build it up. I think I'm just going to leave that. Print over network. Print over network. I don't know what that is going. Sending data to printer. Turn back to me. It looks like that thing is waking up over there. So that is cool. We're not gonna see the result of this because I am done live streaming before this. But now the 3D printer should start hopefully moving around. I thought that was maybe just exciting to do that. Thank you, Joe, for sending that. I hope that was useful. I hope this was just another way to do this. You know, like I'm doing these videos. I'm not always doing it the most specific way for that thing. Just trying to get the juices flowing. You let thumbs up if this was good. Thumbs down if you think this was stupid. I hope you learned something. That's really all I'm trying to do. All right. Next one is from Lee. Lee had sent me one email where he was trying to move something and then kind of figured it out himself with the move command. I did use the move command earlier when we used this one. So this video here showing using the move command with the sketches. I did do a video. If you do Fusion 360 and you do move, I think I called it Jedi or something like that. Become a Jedi with the move command. Last live number 35. You can also just search that. If you go out to YouTube and search last live 35, that video should come up as the number one. Oh, you're not seeing my screen. Out here, search last live 35. You will see that one. I go through the move command. You figure it out yourself, Lee. Glad you let me know. Hope that was useful. 3D printer is not going yet. He was saying, maybe I didn't do something right. He's saying something about changing configuration material. Maybe I had installed I'm not gonna do that now. I would have to go back into Cura. I'm not gonna do that. Let's move on. Sorry. I was hoping you got it to see it running in the end. Next one is from Magnus. Magnus, hey, this is Magnus from Sweden. Hello, Sweden. Thank you for sharing your knowledge. You're so very welcome. So Magnus is talking about using engraving inside of Fusion 360. I'm not going to jump in and do cam right now, but I want to share the pictures that and talk a little bit about it. So Magnus is bringing up a good point, and that is that he has these letters, and he's looking to use the engraving tool. Now, the engraving tool, this is what he gets out of Fusion, but he actually wants a combination of these two, where one will go in and will kind of clean up the bottom, but still go out in an angle and kind of pick out the corners. And Magnus, I think it's a little bit of a difference depending on what you're looking to do with Fusion. Because if you go into Fusion and you go into 2D, you will see you have the engraving toolpath. The engraving toolpath, the main thing for the engraving toolpath is literally to do what you see in your image where it goes out and digs out the corners. It does not look, even if you're using a cutter that is flat in the bottom, it's not really looking at that. Now, if you're looking for flat within Fusion, you will have to add a couple of different toolpaths together. And the reason for that is, and one of the things that Magnus talks about is that he's using easel, and that one can do it. And that's because easel is based primarily on woodworking. And in woodworking, that's what you do. You engrave, and you engrave a lot of letters and different things like that. The cam inside of Fusion is based on metal. So shop floor type, machine shop type cam. So that's why that these tools are looking a little bit different. So when they wrote the engraving toolpath inside of Fusion, it was primarily because people would take the letters inside of Fusion and they would extrude them into to the blocks. This was before Fusion got stick font, because in a machine shop, when I used to do any lettering engraving, it was just to engrave a part number into a part, for example, or a fixture, and I wasn't looking for it to be all beautiful and pretty, so we were just using stick font. Now what they did was, the CAM development team did, was that they said, we didn't have stick font, we have it now, but when we didn't have it, they were like, how can we get past that? And that was just using the engraving toolpath. So my long answer is that you can absolutely achieve what you want to achieve, but you are looking probably to do a combination inside of Fusion with a 2D pocket with a flat end mill to flatten the letter, and then maybe looking at to use more something like a chamfer toolpath to get that angle on the letter. So the engraving toolpath was meant for something a little bit different than what you are trying to do. And this is just going to be, a little bit of this dance. I'm talking about this all the time. Fusion being a mechanical CAD system, but it's really lots about nuts and bolts. So when you're trying to do body armor for your cosplays, that's not the strength, though you can use T-splines. Or if you're doing a lot of engraving in wood and things like that, then you know that the CAM toolpath is based on machine shop toolpath and not so much for, complex wood carving and inlays and things like that. There's workarounds, but you should be aware of that. All right, that was that. Next one is from Noah. Noah says, hey Lars, I really appreciate your videos. I really appreciate you watching them, Noah. So one of the questions he has is, he's also trying to do a sci-fi looking coin bank. Isn't this interesting? In this live stream today, we did a coin bank with the cam where the coin was going to roll down. Beginning first one, we talked about Ash's question about sci-fi, and now it all coming together. Whew. But he sent a picture. Okay, hour and a half. I gotta wrap this up. Just trying to answer as many of your questions as possible here. Here we go. Here is our sci-fi coin bank. So the question is, I am trying to design this coin bank. I'm looking to add some slots through the blue so you kind of can look inside the coin bank. But how do I add these slots in here to kind of the holes for some? You want to put some screws in here. I love where you're going with this. How do I do this inside of Fusion 360? So I think this is a perfect, good example for us to wrap up this one with. Let's go in here. I'm just going to start a sketch on the top here. I'm going to make a slot. I'm going to make this 50. I'm going to extrude this up as a solids. And this here could be our coin bank. And I'm thinking that maybe we want to do this out of maybe we want to do this as a glass. So we have some kind of a blue plexiglass thing. And then we want to add this sci-fi on the outside. So let's do that. So let's go in here, open a sketch down here. And I am going to hit P for project. This here. I'm actually going to do an offset. Let's offset that out. Let's make it 2 millimeters maybe. Just so it has a little bit of things to it here. Let's draw a line out like this, and make sure this point is corresponding. So that's D for dimension. Let's make it 40 degrees. Do I like that? I think actually probably had a smaller. Let's make it 20. Like that there. Do we like that? I think we like that. And let's, while we're in sketches, don't forget that you could actually mirror a sketch line over another sketch line. That would probably just mean that I have to create one more line. Be a construction line. So let's mirror this line over this line there. Finish that sketch. Let's hit Q. Oh, did I do it? Yep. Do Q. So like that. That's gonna be kind of like our armor going up there. I'm actually gonna be a little fancy, if you don't mind. You might know I'm gonna go ahead and say not from the profile, but offset the plane of this one up. I'm gonna go up 10 millimeters, and then the distance is not gonna be a distance. It's gonna be from to object. It's gonna be the top there to that object, but I'm going to offset it also by 10. Minus 10. There we go. I'm not gonna join it. I'm gonna leave it as a new body and hit OK. I hope by going through this somehow, somebody right now is like, whoa, that's what I needed to learn. I'm gonna go in, I'm gonna mirror this also. I'm gonna select it as a feature because I like features. Select that feature over that center plane there. Now I have it on both sides. I'm gonna hit A and I'm gonna change. I don't want this to be glass. I want it to be leather. I want this to be, now I'm just playing. Paint. I'm gonna paint this blue. Yeah. Like that. But that's not the blue I want. I'm gonna edit that. I'm gonna say I want it more like that blue. How do you think that? Okay, so now the question from Noah is, I want to put some screws in this, right? And I want to put some slots into this. How do I do all this so I can kind of like look through and look at that? So the first thing is that if we're going to put some screws in here, where do we kind of want those screws to go through here? So what we could do is, I don't really know where that angle is right now. There's a couple of different ways you can do it. If you go into this construct drop down, one of them would say, I want to create a plane on an angle, or you could say a tangent plane. So I'll show both of them. So one way could be, say, I want to create a plane in an angle, select that, and the line you want to do it about is this center line down here, and you will now see that I get a plane on an angle. So 90 degrees, if we're looking down from the top, is right there. So now we could kind of start moving this and kind of figure out where we think that that plane would be. So I'm going to go here and say 120 degrees. I kind of use that as my reference. Maybe actually I'm going to make it minus 115 degrees. I think is good. Now I have this plane in here. If I sketch on that plane, open a sketch, and I select that plane, now I could create a couple of holes. See the circle? I'm going to draw a circle there. I'm going to draw a circle. Oh, there's an origin right there. Actually, that's kind of convenient somehow. And it's a little hard to see. Bear with me. D for dimension. We're going to make them 3 millimeters. And I'm going to make these two holes equal. So I'm going to select this hole to that hole. And I also want to make sure that D for dimension, that there's a distance between these two. Let's make it 55 maybe. It may or may not be good, but I'm going to leave that there. And I'm also going to make sure that these are black. So what I've done is I've just sketched 2 holes in here. Now, here's a cool thing. When I go in and say Q for press pull, if you can't select anything, hold down your left mouse button. And I can now select that profile. And I'm going to go down, I'm going to hold down and select that profile. You can now see how it's going to cut through there. But here's a little trick. Right now, it's cutting through everything. It's cutting through the glass and it's cutting through the shield. Know that over here, if we click on that, we can choose what body we want to cut through. So if I uncheck the glass, now it's only going to cut through that body right there. Boom. See that? Now I could also, again, going and edit that, edit feature. I could say that I want to cut, I'm going to cut in one direction. Maybe I say I'm going to cut symmetrical. And that means that now you will actually see that I get 2 bodies because there's the other body over here. I hit OK to that. And now it cut through those 2 bodies. Then I could decide to just do, what could I decide to do? I could do a circular pattern of features, our 2 cuts through this axis. Right there, right? And now you could start to do some kind of a rotation. I only want 2 of those. And I don't want them full. I want them in an angle. It's going to appear somewhere. I want one there. It should show up, shouldn't it? Optimized. Oh, that didn't do it. Well, let me just select faces. I select these faces, and I select these faces. And I want to do it through Z. And I'm missing something. There we go. Now I got through all of them. I might have to play a little bit more with that one, but it's getting late. So that's one way we could do something like this. I hope this was useful. At any time now, we could go in and say, you know what, I think that 3 millimeters was a little stupid, actually. I think I want them to be 2. And then everything would update to that. The other way to do this, Noah, would be, so I just did the plane at an angle, right? You could also do a plane that is tangent to a face. So if I did that and I select this outside face here, select that one, maybe not. Plane, tangent. And a point. So if we go ahead and select this face and we select this point here, then you will see that we could also get that. So what you would do here was you could go ahead and this maybe takes a little bit, that's a little bit, maybe a pain in the neck the way I'm going to do this. Alpha line and create a line out here. And I'm gonna make that there. So I have that sketch. Select that plane for a point, this face. So there. And now I have a plane that is tangent to that face with there. And I could do kind of like the same thing. I could now start sketching on that plane. And I could, now I could do a slot, something like that. Q, press pull, and again we could decide what we want to cut into. And we would kind of have the same kind of thing, here. So I hope that was useful, Nor. I hope that was useful. I hope that was useful to you guys. All right, I had a couple of more that I just wanted to run through quickly before we get all through this, because again, this is just me trying to answer a couple of emails. So Paul sent me an email about doing something with a turn profile with Cam, but you sent me a file format that I honestly am not. I'm honestly not familiar with it. The file format is STC, and I don't know. It's a handlebar cap. So Paul, if you can send me a picture of it or something else, that might be better. Scott Matthews sends me something, and I called this image up a couple of times. We got to talk a little bit about that. Scott is talking about how would I do this kind of braided steel for this stuff here. Now, he also sent this image, so he actually managed to model it up inside of Fusion like this, but he's looking for how to get it to go over itself here. And we did that earlier with this one here, where I talked a little bit about how you can go over this here. But the truth is, Scott, that unless that, if this is for a picture, I would do this in Photoshop. I would not try to model this up like this. I would try to find another way to do it, just because Fusion is a mechanical CAD software, and you could be asked to make an image like this, and you could use Fusion to do this, but I would Photoshop this texture on here. There's just no need to do it in Fusion, I think there's other better tools out there. But good job on what you did with it inside of Fusion. And hopefully now, if you want to, you saw how I did the thing of overlapping it, and hopefully that's useful. And last one was from Thor. Thor Magne is trying to create a small cock in a ring that goes in a large cock in a ring. And I don't know if I maybe actually forgot to save this out as an image. But if we look at, I did. If we go here and looking at something, I would think it's like something like a gear tooth that could, something like this, that could rotate in a bigger outside ring and kind of like model that up. I've talked about this before, Thor. Machinist Handbook up on the shelf up there. You will you could kind of model this close, but Fusion being a mechanical CAD software, I would go up in the Machinist Handbook, find out a gear ratio, and you would start modeling that up. I have done some videos on how to do something like that. If you search Fusion 360, if you can spell Fusion 360. The sprocket is probably the closest that I've gotten. You can see that John, one of my heroes, did a sprocket and chain. Go and look at some of those videos and see how you model that out. That is where I'm going to end this one. I think this one was good, man. When you're looking at what we got here in Seattle Fusion, so we modeled up some sci-fi piggy banks. We did a towel rack that I'm going to start printing now. Some overlays. Can't remember that one. Ooh, what about when we brought in the sword as OBJs? We talked about OBJ files. That was kind of cool. twisting some metal in here. My garage, you saw my workshop. I'm thinking about maybe doing a video where I'm actually showing where I'm sitting and stuff like that, just to give you an insight. But with all this, that is where I'm going to end this number 11th of the Sunday edition of Asking Lars. And again, I'll break these out into smaller chunks for you guys to watch through the week. I hope this is useful. It's just my attempt to add a little bit more value to your Fusion 360 experience. If you haven't already subscribed, it would mean the world to me. Thumbs up if you like it, thumbs down if you don't. I love the comments. You guys are awesome. Really appreciate all your guys' feedback. Until the next time, I hope that you have an awesome, awesome day and an awesome, awesome week. Take care, folks.